Okay, so this is very difficult because Cameron is such an like indescribable guy. Um, you know, yeah, this is very, very, very difficult. I know Cameron just as like the guy who, uh, you know, he's like the guy crazy enough to just like dig through the mountain and do just like a sudden, sudden, huge amounts of work. Of like, oh, I cloned an application, or I did this, and then at other times he, goes and becomes a web developer, and then complains about like not being able to program anymore. So anyway, can we get a round of applause for the completely undescribable Cameron Reikes?
What's up, Creiksters? Let's make some noise! Let's say you wanted to write a program that could tell the difference between a cat and a dog. I want you to actually think about how you would do this for a second, okay? Imagine you were given the pixels and you had to make the program that said, cat or dog. You might try something like, look for ear shapes with edge detection. Maybe like detect like the little angle there. If it's a pointy ear, it's a cat. If it's a floppy ear, it's a dog. Problem solved, right? You don't need any more tech. You don't need any fancy whatever. Uh-oh. If we look at our program here, it's just a system with an input and an output, right? Take in the image, and then look for whatever heuristic we've decided we're looking for, and then we make our output, right? But if we keep trying to iterate on this, it's like, okay, maybe some of them have pointy ears, but only fur is orange, and we try to keep coming up with patterns that try to get at what we mean by dog or cat. You'll realize that it quickly becomes untenable, right? So the whole idea of machine learning is you essentially have a program that creates that program. It's basically metaprogramming, right? That's sort of a metaphor for what it is. You set up some architecture and repeatedly optimize with respect to your examples a machine learning model, a black box of many parameters. It's a learned program, right? It's automatic programming. As a quick aside, why is it all Python? It's because it's basically metaprogramming, right? It's a complicated build system. These training scripts basically are just there to eventually, automatically create the program that does what you want it to do. And most of the heavy lifting is not necessarily done by the actual code you write anyways. It's done in the dot products on the GPU or, piece of compute that you're using to actually do the machine learning. And John Carmack, for his current AI efforts, he's in the race to win the world. He has switched to Python. I thought that was notable. So a little bit about me, right? I'm mostly a game developer. If we go back to 2017, one of my first projects was a game engine. I think this is probably pretty common for people who, I don't know, like to program. Is the first thing they try to make is a game engine. It's kind of funny. You don't know anything about what you're doing. You're like, I'm gonna, do the thing that's the ultimate thing. And then much later, 3 years later, it's like I'm making a lot of individual games. I'm working on the Godot engine. These are a couple of my game projects. That there on the upper left is a space game called Asterisk. It's releasing in 2035. It's got something like a Overwatch netcode in it, right? It's like a big solar system with many people playing at the same time. I was pretty proud of how stable the netcode was, considering how chaotic that game was, right? And then Dante's Cowboy. This was no engine in C, 3D rendering, animated armatures, all from scratch, and all the NPCs in this game were they were controlled by an LLM, and this was never released because it's fundamentally flawed. I'm a deep learning hobbyist. The majority of my work is not in deep learning, so there's going to be some inaccuracies in what I say. It's just always been interesting to me ever since back when I started, first doing games. I've also been kind of looking at deep learning, which is a subset of machine learning, and it's just always kind of interested me. Like, I've been following it, right? Ironically enough, actually, my first ever professional programming experience was to architect a deep learning model from scratch, make it work, and deploy it in production. This was for my college roommate's company called MacroHard. He basically made software that was a custom broadcast overlay for League of Legends teams, and I made a deep learning model that predicted which team was going to win the game, right? So that little visualization there is what I created. This was trained and and optimized on many professional games. And it's just a pretty interesting problem, right? And at that time, right, I implemented a League of Legends game predicting paper, and I couldn't reproduce the results. I was like, well, I copied the thing that the paper said to do, and then it doesn't work. And basically, there was a bug in the paper, right? This is a very important lesson of not just how hard machine learning is, but how often people mess up, right? And how easy it is to mess up and be so confident in what you did that you publish it to the world and waste my 2 weeks. Like, it's just very, very easy to mess up. And just to give a quick overview of the bug they had, right? When you want to make sure a machine learning model works, you usually you give it a test, just like a person, right? And if that machine learning model were to see the answers of the test before it took it, its success in that test would obviously not be representative if it could do the true problem, right? Arbitrary new examples. It's not evidence that it generalizes. And in this specific case, they had a metric, the champion win rate, that was trained on their entire. That champion win rate was based on their entire data set, right? And so then when it went to test the model, it had the win rate for the champions that were in the test set. And so it purported to have amazing accuracy at predicting who would win on the test set, but there was data information pollution, right? These are the kinds of bugs you find in deep learning. They're not something you could really breakpoint in a debugger. They're things you have to find like a scientist, right? You almost have to binary search over the problem space sometimes to see what's going wrong. It could be anything, right? And I want to stress again that machine learning is automatic programming, right? In this paper, this is a machine learning technique, not a deep learning technique, called random forest, where it's basically a series of learned if statements directly, right? And there might be some majority voting scheme, and they have some algorithm to optimize, based on the training data. Oh, this if statement should be this, and this if statement should be this. They basically are attempting to tweak the if statement such that it is as accurate as possible on the training data. And deep learning is separate from that. It's a subset of machine learning. And the story kind of goes like this, right? Some guy in the 60s was looking at this, and he was like, I think I know what these are. He was very foolish. He basically, on a very abstract level, said, okay, you know what neurons are, you know what's going on in the brain, you know what's enabling us to do all these amazing things, is little, boxes. They take in a bunch of numbers, and then they mutate those numbers somehow. Maybe when they have enough of that number, they activate and propagate that information to the other neurons. If we were to zoom in really, really quickly on what one of those, very abstract human neurons that they designed is actually doing, right? A single neuron in a neural network, right? The first step is it adds all the weights multiplied by the incoming activations, right? So you see that bigger arrow is a much stronger weight. That tiny arrow, you can even have a negative weight, right? There's basically a set of weights coming from the neurons on the previous layer, right? And then it just adds them like numbers. They're all floats, right? Next, there's a bias that adds a bias to that weighted sum. So this could be considered like the activation threshold for that neuron, right? So if the bias is -6, then you would require 6 to be above 0 and to continue to propagate that information. Again, this is a very rough, bad model of biological neurons, and they stumbled upon something that's actually pretty crazy just by doing that, right? But the final step is to pass it through any nonlinear function, like sine or x squared. I'm gonna get to why they do that in a second, right? That's what happens in a neuron. Here's some pseudocode for how you would find the float value for a neuron, right? You could take a look at this and ponder it for a second, but you'll notice that, well, if we're constantly just multiplying and adding numbers, that's kind of what linear algebra is, and that is how they accelerate this and talk about this in the actual field, right? They don't express each individual weight in some kind of array. They express it as a matrix, right? And then there's a lot of math that applies when you do that, right? You optimize those weights and the bias with a process called gradient descent, right? Stochastic gradient descent. I'll also get to that in a second, right? But fundamentally, this is just a diagram for this expression or that code, right? When you see this diagram, it is simply that code, right? That's what it's intending to describe, right? And so just to kind of get at what's going on with the activation function, why do they pass it through sine, right? Each layer of a neural network is basically a node in a transform hierarchy of n dimensions, right? So if you're a game developer, which you're the target audience of this talk, so you should be a game developer, you're very familiar with trees of transforms, right? And you know that if you have a series of transforms one after the other, you can multiply them all and it becomes one linear transform, right? That's what it means for something to be linear. And when we want complicated behavior from these deep learning models, we don't want it to be reducible like that to one linear translation and rotation and whatever, right? So you basically think about it as warping the space such that the translation and offset you do kind of it enables you to basically draw a much more richer contour around the data, right? And so just as another metaphor to help you as a game developer understand what's going on here, right? Both that neural network and that shader graph, these are both compute graphs, right? There's no branching. Information is flowing in from the left and it's going out the right. A shader operates on vertices while a neural network operates on an image or some state or anything you want, right? And in the case of game development, an artist might be manually tuning the inputs to that shader and making it look good, right? They might be nudging, the color and trying to make the output look good or some other parameter. In the case of deep learning, that's actually replaced by a machine, right? Which is which direction minimizes error on training for each one of these little parameters, right? Each one of those weights, each one of those biases, it knows which direction it should go in, assuming all the other parameters were, not moving. It knows approximately which direction to go in to get better at the task, and then it just kind of repeatedly does that thousands and millions of times. So there is a code base for this talk. It's here, github.com/Creikey/AI. And to just get at what this code base is supposed to be for a second, right? Deep learning libraries, or AutoGrad, they let you perform some arbitrary, computations, right? It might be a matrix multiplication, it might be x squared, or one of those activation functions we talked about, and then find out how you need to turn or adjust those parameters, right? The weights and the biases. It automatically figures out what the expression is to make those move in a direction that makes the model get better at the task, right? And that's basically what these deep learning libraries are supposed to be in a nutshell. TensorFlow, PyTorch. And just as a little preliminary for this code base, there's a lot of tensors in it, but really tensors are just arrays of matrices. You might want to talk about we're feeding in many examples into this deep learning model, and so we want a third dimension to it where it's just an array of the matrices that we're feeding into the model, right? And so my idea with this code base is it would be really cool if instead of me having have a Python interpreter, there was one C file called ai.c, right? And we had CPU and GPU, deep learning, computer vision algorithms and implementations, right? I would want it to be able to execute local LLMs, right? I want you to be able to fine-tune those LLMs, not just the inference. I would want to hardware accelerate with something portable like SoCal, right? Some computer vision algorithms as well, because those are fun. Now, unfortunately, this talk code base right now is super not that, right? It has a hand-coded gradient calculation for a two-layer perceptron that classifies digits. It's super primitive, and it's 1970s stuff. There's no working AutoGrad yet, but I almost have it working. And I intend to continue working on AI.c because it's kind of fun. I'll be sending updates in the BSC Discord about that. But just as an example of what it was trying to do with this little tiny, deep learning library is each of these videos are videos I got from YouTube of some kind of idly animating a scene, right, where the camera is stationary. The theory is you should be able to train a deep learning model to generate these videos from the image. The assumption is that the behavior of the pixels is relatively simple. And so I actually, even though I wasn't able to get this working in time for the talk with AI.c, hold on, sorry, one sec. Oh, here we go. Okay, so I basically just, let's just try it in Python really quick to see if this will even work at all. This is an 80 kilobyte of parameters neural network, and it's garbage, right? This kind of happens a lot in deep learning when you just have a random idea and you just try it. It makes something really, sometimes hellish. I don't even know what that is, honestly. I think that 80 kilobytes is way too small to encode the dynamics of a waving tree, probably, so I would just, 10x it. Deep learning is just very experimental like this. It's not exactly known, what would cause the model to correctly learn how to idly animate that scene or make the clouds move, which is what I'm hoping for, right? You can imagine with a model like this, you could take any desktop wallpaper and just make it idly animate in the background, right? Especially if you got it good enough on the battery. It might be kind of fun to, minimize it and then see stuff always moving. So just as a little bit of a historical detour, right? That what I just explained to you, that deep learning model, the perceptron, this is an article about it in 1958, right? They were saying it can tell the difference between a cat and a dog. It is of no practical use. One day it might be useful to send one into outer space to take in impressions for us. So AI has always been a grift, basically, right? And it's followed basically this phase where all the investors pour their money in and they're like, this is going to be a new form of life that will do our bidding, right? And then it doesn't work, and then it happens again, and then it doesn't work. And now it's happening again, and it's, who knows what's going to happen. He just says, what did we learn, Palmer? And so me personally, my kind of like AI boom bust was I got really into deep learning, and then right when GPT-2 started to happen, I was like, this thing's kind of nonsense and it's not going to scale. So I basically was like, all right, I'm kind of done with deep learning. I think it's useless. And so it's kind of like selling Bitcoin at $100. I never would want to buy back in because that's realizing my losses. So I'm just kind of waiting for it to collapse again, hopefully, maybe, and then I can buy. And if you think that's a funny joke, in the audience right now, how many of you have any amount of retirement or capital in ETFs, right? Just want you to raise your hand. Okay. Your money's being gambled on the success of AGI right now. Roughly 30% of the S&P 500 is heavily weighted on AI succeeding. AI growth stories, high price to earnings. So I proposed a model of history here. There's basically two grifts orbiting each other, right? Fake money pumps to AI, capital flees to Bitcoin instead of US-related, assets. No more easy capital, no more AI. Deflationary doom spiral where GDP becomes 1/10 of what it is now. This is an idea that it's basically a bubble-generating phenomenon, right? Both of these, one paper basically started the whole. There's like the transformer paper and there's the Bitcoin paper. There's parallels, right? And if you look at this, innovators laggards curve, right? I think we're right about here. If you look at the NVIDIA stock price, it fits the curve. So we're at peak grift at the moment. It'll fall off soon, I think, and so I think now's a good time to short, but that may or may not be financial advice if it works out for you. I do just want to say that shorting, I believe, has unlimited risk, and you, at best, would double your money, so it's probably not a good idea. Here's some examples of just machine learning in general, right? Let's go back to not, being kind of schizo. So this is a little piece of history again, right? This is called Psych. In 1984, some people were very upset at the deep learning people. They were like, look at this arbitrary floats and numbers. I want an interpretable program that's intelligent, right? So they basically set out to manually program all of human intelligence. And the theory was if you just throw enough bodies and people at it, it'll eventually be smart, right? They've been doing this since 1984. Okay, if you ask the system questions like, if I put a cup of coffee on a table and then I push on it, what happens? It'll say it explodes. It's still not working very well, and then the reasoning traces are 1,000 deep. It's kind of nuts. It didn't really work, right? First of all, the reasoning isn't even understandable. This approach just doesn't, it's called symbolic AI, right? And I think that there's actually a modern parallel, right? Waymo is like Psych, that project where they were trying to manually encode intelligence instead of automatic programming, right? This is deep learning is really a new paradigm of programming where it's automatic. You're automatically creating the nonlinearities that do the thing that you want the computer to do, right? Waymo, they basically scan the city and they put a bunch of if statements for where the car should go, so they're very slow to roll out. So Tesla has basically just recorded millions and millions of hours of just people driving, and they're training massive, massive transformers on human behavior, and they're just trying to model it, right? It's also, there's another parallel with Siri and Echo Dot, right? These are symbolic systems. They're often frustratingly unintelligent. To add new intelligent behavior, an engineer has to basically, design the algorithm and all that stuff. And ChatGPT is statistical. It's deep learning. It's automatic programming, right? Deep learning models don't learn. That always bugs me. I think it's a misnomer. That's like saying when you're a game developer, you're creating a universe. It's a very hand-wavy way to say something that I think is really mechanical and mundane, right? I think it's more accurate way to describe what happens with deep learning is optimizing, right? And it's an automatic optimization. Here's just another side note, right? So there's big copyright disputes with these deep learning models, right? And I just had a funny idea, right? You could almost make the argument, if you take the argument that the deep learning people are trying to make, right? They're trying to secure their bag. They're trying to say, well, we learned the patterns from what you gave us. We didn't, copy the pixels or whatever. That's what JPEG does. It learns a model of the pixels. And so it's almost like arguing that because, it's JPEG and not PNG, because it's a model of the pixels, I didn't steal your thing. So it's a little strange. Right? I think that's kind of a bad faith argument because the patterns that are found in deep learning are very generic and they're not so specific to the image, and so it's very debatable. I'm not sure what's going to happen. But it's just to go back to my League of Legends task, right? If we just want to think about that a little bit more as an engineer, you might naively just put in the current state of where all the people are on the map, how much gold they have, what items they have, throw it through that perceptron I showed you, and maybe it'll automatically find ways to relate, when the gold in this item is here, then they're more likely to win than you would think and stuff like that. These are the kind of patterns you hope a deep learning model finds as it optimizes based on massive amount of data you have, right? There's a problem with this, though. What about past states, right? Past state informs the nature of present state. If somebody was performing badly on your team in the past, right, they were running it down mid, this should inform your current prediction heavily, right? So this, you need a recurrent neural network for this, right? A recurrent neural network is basically two of those perceptrons that I showed you. One is modifying the state almost, and then another one is visualizing the state towards whatever like you want it to visualize, right? It might be probability for who's going to win, or it might be like you could replace it with another deep learning network and train it to visualize like, I don't know, which champion is like has the most synergy with the other champion, stuff like this, right? It has state. It's much more like an automatic program, right? Automatically learned program. The hidden state of a recurrent neural network is like RAM. It's now just a RAM. And that is why I think that these are best described as automatic programs, right? And so what I did at the time to successfully model who would win in League of Legends games was I selected a GRU architecture, and I spent weeks tuning it in messing around, and I managed to make it so halfway through the game it could predict who would win with 86% accuracy. If you just went with whoever had more gold, it was like 73% accuracy. And then this continued to generalize even on arbitrarily new games. And just as as a side note for game developers, you could use a technology like this for a play of the game kind of feature, right? To see big unpredictable swings in who's winning. We actually did do that. We took our giant corpus of professional games, and I ran this model and saw what were the biggest swings, and we looked at those games, and they were the most exciting matches, right? So this is kind of like just to give you ideas for like what this technology can be used for, right? Each perceptron in a layer is like roughly analogous to an if statement in the program, right? Like another branch, it lets you make a more specific contour around what you're trying to encapsulate, right? You're adding more resolution to that boundary. This is why it's called deep learning, because once you add many layers, you can make very complicated behavior, right? The problem if you just take that perceptron and you add a bunch of layers is it adds way, way, way too many parameters, and the gradients get very tiny, right? It doesn't optimize, right? The optimizer doesn't work. I mean, you saw my failure of deep learning. It's not easy. You almost have to like guess and check if you really aren't, branching off of some established, known working architecture, right? And so all of the field of modern deep learning is basically about how do we add more parameters to this model and still get those parameters to be optimized into something that generalizes to what we needed to do, right? In the case of a convolutional neural network over here, they kind of start with the inductive bias that like, okay, when you're looking to see if an image is of a cat or a dog, and you basically are hoping that, let's say this deep learning model will pick up on the pointy ear thing, it doesn't matter where in the image that pointy ear is, right? They basically want these deep learning models to learn, features that it doesn't matter where they are in the image. If you just fed every single pixel and all the RGB values into a giant perceptron, then it would have to learn that cat ear means cat in every single spot, right? That's not really what we do when we recognize images, and so that's like a little bit of key insight. That's what deep learning researchers are trying to do, is like come up with ways to formulate and structure the computation, the graph of computation, such that when you optimize it, it gets what you want, right? And a transformer on the other end here I'll talk about in a second. This is another example of an architectural change. You can add way more parameters and it's still stable and it's still optimizing correctly, right? Just as another little side note, some deep learning techniques are a little silly. This is called dropout. You randomly turn off neurons during the training. It's supposed to prevent memorizing the training data, and hopefully make it so neurons aren't exactly specialized. Like, who knows why this works, honestly? I haven't seen any real convincing argument in any paper for what exactly this is doing. Like, basically what's happening in deep learning is people try stuff and they have some very like, okay, yeah, that sounds about right. I think that's what's happening. And then it's like, there's no rigor in this field, basically. Like, it's really crazy. This is actually used in production for ChatGPT. Without it, like, it wouldn't work, I think. And it's like, we just randomly turn off the neurons during the training. Like, okay. So there's a zillion videos that explain transformers already. I'm not going to give you an explanation of the transformer, which is, the cause of the current grift, right? And, you can watch any of these and they're good and whatever. But I'm just going to give you a quick overview. This is a single slide. This is what a transformer is doing, right? It's basically going from a sentence, a lookup table per token, into a point in a space where, like, the closer two points are, the more related they are, right? It adds a position encoding to those points so that, if we have an array of these points, then the points are modulated in such a way that the deep learning models, they can pick up where they are in the sentence, right? They're almost jiggle in a way where, like, you could learn that pattern. I keep using the word learn, I'm sorry. It's pervasive in the field, but I don't like it. And then you literally just stack 100 of these attention layers onto those vectors, right? And each of these attention layers, every single time, every single one of those tokens, right? It's basically looking at all of the past tokens and enriching the current vector with more information about the surrounding tokens, and then more facts potentially about that information in the form of another perceptron, right? It's like learning what facts might be related to a word like house, right? It continuously enriches each one of these words with more and more context, right, in a highly parallel, easy to train manner. And then there's just this 2-layer perceptron, and then it gives you the next word, and it does that over and over again, right? There are many hyperparameters in this massive system, right? Many things can go wrong. It's like, what is the learning rate? How quickly do we turn these parameters to, make it better, right? It's like a massive problem, actually, to know what, these are called hyperparameters because unlike parameters, like, they're not automatically learned in the core algorithm of deep learning, right? You can try to figure out what they are with a search algorithm. That's very costly if you're OpenAI, and each training run costs $10 million. And as it turns out, we heard from an insider here that most of the big gains from these, most of the state-of-the-art models that come out of OpenAI, they came from so-called YOLO runs, where they basically asked Karpathy or one of these, like deep learning generals, like, hey, we're going to give you $20 million to just try something, right? You just pick numbers, pick hyperparameters, pick whatever you want, and we'll see what happens. And state-of-the-art model, right? It's basically vibe engineering. Vibe engineering created the vibe coding machines, and everybody's just vibing, and then we're being wire-headed, and then it's over. Well, I think that it's a very interesting question. Can these LLMs reason, right? So they can't reason because they're not human. I think that's a good way to use the definition of reason. But let's say we want to figure out if these LLMs can, output text as if they were reasoning, right? I think that this benchmark, ArcAGI, it's a stellar benchmark for this task, right? If you take a look at this diagram here, right? That's one example, and that's another example, and you have to predict what happens here. If you're human, which I'm assuming all of you are, it should be pretty obvious to you that you basically just put the yellow dots, like where that little corner thing goes. And ArcAGI is the kind of benchmark where they basically take random people and they're like, all right, we'll give you a $15 Starbucks gift card if you solve this problem. And they verify that, like, people can just figure it out in a context-free manner, right? And so the whole idea with this is they're trying to find problems that, like, average people can do, but, like, these LLMs, they can't do it at all. And ArcAGI, they were originally, totally defeated by OpenAI's latest reasoning model. It got human baseline on a huge suite of these that are private, not anywhere existing on the internet. Generic. Each ArcAGI problem requires a new, unique insight. They're basically puzzle game problems, right? They require some kind of like, oh, that's how it works, right? And LLMs have already beaten the first ArcAGI benchmark, which that was quite significant. I didn't think that would happen. And neither did the author of the benchmark. He's a massive skeptic, and he thinks it's a bubble. And then OpenAI pulled them on stream, and he was like, my benchmark is defeated. So we made a new benchmark that they're all failing at again. And that's Grok 4. A few days ago, they just doubled the state of the art and got 16% of the questions right. So just circle back on some applications to games really quick as I kind of close up on this kind of like lightning overview of this, right? Any problem where you have input to output data and it's hard to define programmatically what that mapping is, that's where you would throw something like deep learning at the problem and try to automatically program that transformation. This is NeRF rendering. This is a very interesting application of deep learning to the problem of rendering, I think. It's very old, and there's much better techniques like Gaussian splatting. But NeRF rendering is basically given a point in the scene, a deep learning model learns how dense it is, and then it kind of traces rays through that learned density to render. And just as a little interesting tidbit, more vibe engineering, basically deep learning models are very bad at learning so-called high-frequency functions, right? So a little tiny thin metal pole is a very high-frequency function, density function for it to learn. It's like nothing, 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 bam, really thin, nothing, nothing, nothing. It's very like tight, and so it's hard for a deep learning model to pick up on that because it would require a lot of nonlinearity. It would require a lot of layers, right? And so what they did in NeRF to achieve state-of-the-art results for deep learning-based rendering is they passed that position into a bunch of different sine waves, and they basically just made it easier for the deep learning model to pick up on higher frequency spatial information. I thought that was kind of funny. She passes a bunch of sine waves, and then it's better. This is called ASH, animatable Gaussian splatting. So the video works here. This is basically photorealistic human rendering with accurate physics on their clothes done in real time. It's just unfortunately, in order to scan somebody, you need about 100 cameras synchronized, and it's very expensive. So maybe they'll figure out how to make that cheaper someday. But in this specific paper, a deep learning model is used to go from a texture that describes the skeletal deformation of what you want the person to be in into the view-dependent color that you would see from that skeletal deformation. And essentially, you need to train that deep learning model to learn that relationship between like how their arm is bending and what their clothes look like per person. And then, of course, I'm sure probably all of you guys already know, ray tracing is greatly benefited by deep learning because it's used to denoise, right? Deep learning is used in an algorithm called AlphaZero to master any discrete perfect information game. Basically, a neural network goes from the board state to a likely next move in a win probability, and then another algorithm manipulates those probabilities and beats any human in any game we've ever invented. Unfortunately, automatic game AI. So you could make a style transfer. You can make it some kind of style transfer for something like this for your video game, where maybe like you want it to act more like the human people. So once it masters the game, you then train it to act like a person, and then it would be a kind of interesting mix between a good player and, it plays like the specific chess player or whatever. Or you could even have it validate that your game is balanced and stuff like that, right? I think this actually is it's quite greenfield for video games in general for how to apply deep learning models in a lot of places. And for automating like a call center, I think that there's a lot of these call center AI startups. It seems easy on the surface, but usually people call support because they want to talk to a person and not a machine. So I think that this is probably going to be a giant disaster. And of course, automating something like engineering is way more complicated than just that, which isn't even working. So, just something to think about. And a quick note on computer vision, because I didn't really get to flesh that out that much in this talk. But the basic idea I had was, for computer vision, you're essentially trying to take in a bunch of images in something called monocular SLAM and get some kind of representation of the world that it's seeing automatically, right? It's a bit like deep learning, where you have some automatic optimization process that operates on a lot of data to uncover something interesting about the world, hopefully interesting. And that visual SLAM pipeline is basically the opposite of game rendering, and it involves somewhat similar linear algebra, right? You go from an image to easy to try key points, pose estimate for the camera, some representation of the scene for the robot to drive around in, right? Game rendering, it's like scene representation, triangles, pixels. I just thought that was interesting. So will LLMs replace knowledge work en masse someday, right? I put a Steelman yes and a Steelman no here. Really, I think it's probably not, but there's like a lot of investors who disagree with me, so I don't know. New knowledge can't be made by machines, right? This is a very funny joke made by a philosopher called David Deutsch. Maybe this is what we're going to have to do someday. You're going to have to invent new scientific knowledge to prove that you're not a robot. Because maybe that's the one thing that humans can always do is create new knowledge, because they're the only ones that can officially reason. But if, you have to have a human know if you did new knowledge, I don't know how a system would detect if it's new knowledge or not. Maybe that's like P and NP or something, I don't know. Wait until ArcAGI continues to be beaten, I think, is how you monitor this problem. Because if that continues to be beaten, I think, that's crazy. Thanks for listening. Don't forget to check out and work on github.com/Creikey/AI. I want to make AI.c so that it's like fun to mess around with these models and techniques in games. No dependencies, no Python, no nothing. It's not good right now. It needs to be rewritten like 10 times. I've never made a deep learning framework before, but thanks for listening to my talk. Sam.
Is it, what about Lisp? I heard.
Okay, that's a bit similar to the psych stuff. It's used by kooky people for AI, but not serious contenders.
Hello.
What's up?
Good? Yeah. Awesome. Can we get another round of applause for Creikey?
Subscribe to my YouTube.
Subscribe to his YouTube. Watch Eye Contact Practice. It's the best one. I mean, that talk was definitely it was like 15% schizo, but that's why it's entertaining, for sure. I think you're like part LLM. Like anyone that's talked to Creikey, you could just give him a prompt and he just fucking spits out infinite, sometimes he
garbage.
Hallucinates. Yeah, sometimes it's garbage, but most of the time it's kind of right.
Okay. That's kind of what LLMs do, yeah.
Yeah, exactly. So it's in there.
It's interesting.
So everyone here at Better Software Conference wants to write better software and wants to live in a world where there is better software. So will AI cause the destruction of better software?
So, okay, one of the biggest like hot topics for AI startups right now is, well, if AI writes the programs, right, why do we even need an app store? Why do we even need software engineers? You should basically tell your computer the app you want, and then it does it, and then it gives you the interface and the data. And it doesn't work at all right now. And so, we're gonna have to see some new developments, I think, to judge if that will happen or not. I'm basically 90% it won't cause the destruction of better software for at least a decade, but 10%. There's always something around the corner. Grok 4 is like much better for some reason.
Okay. So in 10 years, like, is software engineering a thing? Like, when you walk into a room, are software engineers going to be crafting prompts?
So I've been thinking about this a lot. I mean, obviously, prompt engineering is not going to be a real thing because if you do believe these AI systems will get to the point where they can automate software engineering, they can do the prompting too. I don't think it's that crazy. But in any case, I think that the effectiveness on software, I have been thinking a lot about this question, and I'm still very uncertain. But if software engineers are basically making these like virtual machines that do some kind of processing or transformation that's valuable to people, and these LLMs learned the patterns to create some of these machines as it relates to what you're asking of it, and I think people who are making machines that are very same-ish, software engineers who are making data transformations that are similar to what exists, are going to probably be screwed. But if you're making unique data transformations that are unlike what have been made before, kind of unique machines, I don't see how these models could really create new knowledge like that yet. I haven't seen evidence that they can do that.
Okay. You pointed out something, like learning is different from optimization.
And that's more of a philosophical thing, I think.
Like when a human is born, right? They're born like extremely inefficient, and they just get more optimized as they grow. Is that not the same?
It's not. I think it's not the same because whatever a human being is doing can create human reasoning, and I don't think it's. It would be very hard to make the claim that these things are doing human reasoning right now. I think for a lot of reasons. Oftentimes the reasoning doesn't correspond to what they say. It's like not logically coherent, right? Fundamentally, you kind of understand what's happening here, right? It's optimizing and creating an automatically created program. That might have nothing to do with the universal causal relationship between whatever's happening in your brain, or maybe it's, if you're religious, then it's not even a question. What's up?
Like, isn't the real problem, like, not that AI replaces software engineers and that destroys better software, but that software engineers use AI and that destroys better software? Because that's what's happening pretty much already.
Well, if you believe that society functions, then people will choose the products that are better. So in the long run, I don't know. I'm not sure.
You pointed out Grok had a massive jump recently. Like, did you look into that at all? This is specifically on the ARC AGI test, which, interestingly, there's another ARC. I don't know if Taha pointed that out. I missed it. Everything is ARC.
So yeah, Grok might have performed better because of its utter lack of safety training. That is a rumor I kind of saw, and it seemed to be somewhat confirmed by, in other times, it's like they did safety training and the model got much less, reasonable, in quotes. It might be the case that the safety training is not intelligent because it's so directly refusing to say something, right? There's all sorts of hypotheses, and there's no real, again, rigor in the. It's not really. They're just trying to figure it out. They don't. Nobody really knows.
You're saying like Grok is saying like some schizo like.
It's not good. I don't want to repeat
it's
it.
Not
you
good.
can Google it if you want. It's not good. It's completely out of control. But it is smarter. So, well, I don't know.
Okay. You didn't point out either. Like, what caused this AI, the last AI winter to end, right? Like, what was the
It
insight?
specifically happened. So transformers were made kind of, I think, like 4 years before they were really used to generate text in a very parallel, large, mega data scale way. And it happened when OpenAI, I think, released GPT-2, and they pointed out like, hey, we keep just making these models bigger, and it seems like the text is getting more and more coherent. So if you just complete the line, like someday we get to the thing that makes everybody, Pop-Tarts for free or something, like, and then I don't know. That's what started this massive speculation bubble. It's like, wait a second, we might have a path to completely removing humanity from satisfying our desires in the physical realm.
So it was just they just scaled it up.
Yeah, they scaled it up, and it seemed like the scaling wouldn't end.
Is that what people are still doing? That we just keep scaling things?
They keep buying GPUs. I mean, they're not scaling in the same way. They're not just making the models bigger. They're trying to scale the so-called reasoning models. They're basically trying to make the models more and more correct instead of just making them remember more and more facts, basically.
Okay. I don't want to run out of time again, so I'm gonna do questions right now.
What's up?
So Cameron, a bunch of us have seen your Dante demo just floating around. Can you get into why it's flawed and why?
Yeah, so my whole thinking with Dante's Cowboy is, I think when I saw GPT-4 first, like on the API, I was like certain that this would enable a huge new category of video games. And so I immediately began making like an RPG where all the characters were controlled by an LLM, not just their speech, but their actions, right? And the idea was like, whoa, this thing is basically like prototype AGI or whatever, right? So it'll just kind of operate and it'll be fun and like, and I went through so many iterations of that idea. I made it so that like they could join your party and trade items and all this stuff. And like I played with it a bunch, but it never felt like there was any meat to the game. The problem is games are about predicting and understanding systems almost, right? And an LLM is an unpredictable black box, sometimes acts like a person, sometimes doesn't. It's not fun to interact with in a way where you're trying to get it to do something. At best, you're basically like, hey, trader, I'll totally give you $1 million if you drop your item. And then it's like, this is not fun, this is dumb. It's funny like for one time, but it's not like a game you could master.
It's like the vending machine
Yes.
at Claude.
Okay, right now there's some AI companies are trying to first deploy these LLMs in the real world to start to, create a utopian post-scarcity world where machines make everything automatically. And they're like, step number 1, put the LLM in a vending machine and have it automatically order and interface with the people or whatever. And right now, people are basically convincing these AI vending machines to stock many tungsten cubes and sell them at a loss, and then they go bankrupt. They've published many reports about this, and they're like, we're doing some prompt engineering to fix the business model, and we're trying to make it refuse tungsten cubes more. But really, I think there might be no end to humanity's ingenuity as we battle against the machines for the next few decades. So
That's probably fine, right?
everything's probably fine.
It's
but
not a problem.
Everything's
Don't worry
probably
about it. It's not
fine,
a
but
problem.
sometimes bad things happen. I don't know. What's up?
Do you think so I feel like there is a field of research, I just don't know the words for it or how big it is, but do you think there's a way that we can reverse engineer?
Yeah, interpretability, it's big. Anthropic is the leader in interpretability, I think. They basically do data science on the neurons themselves, and they try to make claims about how the data is flowing through the model. You can look at their Golden Gate model. They have a lot of really excellent stuff you can read forever. It's really cool.
Do you know much about it? Like, do you feel like that is the way forward, or is that just a byproduct of the craziness?
I don't think there will be any value created from interpretability research, honestly, other than maybe optimizing the training process somehow. I'm honestly not really sure. I think they're mostly doing it because they have to, because they want to be the safe people or something. And it's cool, but it doesn't seem valuable to me. But I'm not like a big deep learning researcher. I'm like a hobbyist, like I said earlier, so I'm not really sure.
Follow up to that, is it interpretability that made people figure out you could remove the safety neuron?
You can. They already figured that out. It's called ablation. So any single open source model, you can basically find what's called an ablated model, where they just basically subtract the safety training and then it does whatever.
But you told me it's like one node. It's like this.
Yeah, I don't remember exactly how it goes, but it's not a node, but it's like one vector kind of represents the safety, the refusal. Like whenever an LLM starts to refuse, it always seems to output words in a very, this kind of sounds like the same thing. And basically you can find that inside of the model and nullify it is what ablation is, from what I remember. It's been a while. What's up?
So you said that AI is basically metaprogramming?
Yes.
And GI is very famous for its metaprogramming. Will it replace Python? Like, will we have GI, AI?
So maybe metaprogramming is a bad thing because it's not really comparable. I was mostly, it's like metaprogramming only to the extent that you're producing a program with a program, but it's not like, it's automatic metaprogramming. It's not, mechanistic, symbolic metaprogramming where you're, yeah.
So it would not be a good application for this language, next Node.
Huh?
It's not a good application for GI.
No. Rough.
To bring it more into the concrete realm, you mentioned SLAM.
Yes.
It's been a decade since I've looked at SLAM. Like, is deep learning the current state of the art for achieving SLAM algorithms, or are they still?
I just recently asked a SLAM researcher that, and they basically said deep learning is like used sometimes, but it's not really necessary to solve the problem, though. They've found good heuristics to find the key points that are trackable. And like I think that neural SLAM seems like it's something they've kind of been like rumored, to kind of take over state of the art. But like, the Quest doesn't do any neural SLAM as far as I know.
You mentioned using AI models for balancing games.
Yes.
And let's say you then train a model to play StarCraft 2 and you finally do definitively prove that Protoss should be nerfed.
Yes! I'm glad this struck a chord.
Once you nerf Protoss, do you then like, okay, cool, now we do a $3 million run again?
I don't think it would be that expensive to do it on a game. It's the cost of AI right now is because to make these large language models learn, reasoning, you have to basically shuffle the entire internet in and out of multiple accumulate ads. It's really nuts how much data they have to process. For something like StarCraft 2 or AlphaZero, it's really not on that scale of cost. I could easily see many, many, many games being able to do this, and for simpler games, you could probably do it on your laptop even, maybe. But yeah, like I think that for something like StarCraft 2, it's like I could see them doing these kind of studies if they have the capex and they believe it's, it's valuable for the players to have it truly be officially like even the genius master AI players of this game. It's even, right? That might be a good thing to prove. Yeah.
Would you say that like training is where like most of the cost is, or?
Actually, well, OpenAI says that inference is their biggest cost right now, but there's a massive push to make on-device inference chips. So I think that's kind of temporary, and it's just because like my understanding is, I don't know if this is exactly true, but I've seen this floating around that NVIDIA cars don't have enough VRAM to run these models simply because it's not something consumers wanted, and they kind of want to nickel and dime you for VRAM. And so this seems like the kind of thing where, if it's a healthy market and, there's not like an NVIDIA monopoly or whatever, which there is, I'm joking, it's not going to get better. But ideally, I think it's totally feasible that the inference cost is zero for the people who are making these models. It should be zero. Yeah.
Yeah, in your little experiment game, how did you translate basically the LLM output to actions in your world?
So basically, you can view putting LLMs in a video game as, so you have your game state, and then there's like the physics simulation, kind of like, human in the loop, like you're inputting actions and state 60 hertz or whatever, and there's a text adventure way to interact with the game simultaneously, right? And a good way to check that like the game was properly presenting itself to LLMs is if you could flip it, and as a human I could play the text adventure version of it, right? That's how you would know that it's being represented well in text. And that's basically what I did, is like a structured text adventure presented to the LLMs, describing what's around it, describing what you're wearing, whatever, yeah. Yeah.
So right now when I use some programs, I go, oh, I want to do kind of this thing. And it used to be that I was able to Google, how do I do X in program Y? And there'll be like a forum post. But now you can't find those anymore, or I'm doing difficult stuff. So my question is, what year will I be able to put like a good version of Clippy in my programs? So like there's a little dude, you can actually describe like, hey, I'm trying to rotate the mesh in this way. Like, how does the subself node work?
There's so many startups trying to do that. It's
like Cursor, right?
No, well, it's not even Cursor for X. It's like, there's so many people who put the little chat window on the thing, and it's like, ask it a question. I just feel like they never work. Like, they still are just so bad most of the time. Like, I don't know when it will get good, but honestly, I find that when I use LLMs to understand how software works, it gives me an incomplete understanding because I'm not really like traversing through the whole set of knowledge, right? I'm just specifically getting the answer I need and implementing it and moving on with my life. Whereas when I read documentation and like actually go line by line and sit down and understand it, I just know the unknown unknowns, right? Because I explored. And so LLMs to say, how do I do this in this program? I'm actually not even sure that's good UX, basically.
But if you can like search the documentation, so like you make documentation, you put the documentation, there's like 100-page PDF documentation of this program. I'm not going to read that.
Yeah, it is good for that. Like LLMs are almost like it's like a better Google almost, which is why they pivoted their entire company to LLMs.
Will I be able to, so what year can I expect to like put one of these in my C program?
Where it's like running locally?
AI.C. Yeah, because I want to
Yes, my AI.C project.
to get the guy in who like sometimes complains.
Let's say smaller models are always getting better and better. Let's put a release date on it and say 5 years.
Okay.
So have you seen like a model that sort of can work outside of the training data? It feels like there are always like weighted averages of the training data.
It's not a weighted average of the training data. A better way to describe how they process and how our models impacted by training data is they find patterns and then we run tests on those patterns to make sure they generalize and they're not specific to the training data. So they find patterns which are general that do the thing you want it to do. ArcAGI specifically is a benchmark for generic, never before seen on the internet patterns that fail LLMs, all of them. They're private, they're never leaked or exposed. So you can't build an algorithm that interpolates from existing solutions to solve ArcAGI ever, and LLMs did that.
Yeah, I was asking sort of about the answers you get, because it feels like you get sort of, you cannot go outside of what it has been taught, right, or sort of optimized on. But maybe you could sort of extrapolate some, outside of it. But is that happening?
Yeah, I think that like when you get to these absurd levels of scale, there's almost nothing outside the box if it's predicting the entire internet. That's basically like a huge amount of examples of the dynamics of human intelligence recorded into written form that you then process and find patterns which apply across many examples. That's what they're doing. Deep learning systems usually start with very low frequency generic patterns, like, oh, there's a period every so-and-so words, and then they start to get to higher frequency patterns and more specific, more nuanced things, and then they're basically pattern finders. Patterns which apply on not just the training data. That's the whole point of being like a deep learning person, is you make sure that the model does not just apply on the training data. That's like the point of all the architectures. That's the point of like, doing everything you're doing is making sure that it's not just memorizing the training data, that it's finding patterns in the training data that will apply in your specific task that you need the model for.
So sort of like, say that you recognize images, and like you can recognize cat and dog.
Yeah.
But like a model that can train on cat and dog images, but also like this is something else, like without you showing something else.
Yes, I mean obviously that model is not learned patterns which would generalize to is it a turtle or not. It would try to bucket it into cat or dog because that's what that system has done. But you can feed any image into an LM right now and it'll tell you what it is, almost like exactly like what a person would say. Obviously it's not perfect and it constantly fails, but that error is always decreasing as they fix bugs, they improve the training pipeline, they improve the data they give it, and then it's always approaching something that seems like it will apply in any situation. Of course, it's very far from that right now. I'm not meaning to claim that like you can take any image and then it'll perfectly recognize what's in it. You can fool them all the time. It's just that like it's the entire internet, right? That's the thing that I keep thinking about. That's just a lot. It's hard for me to even comprehend what the limits of that is.
So even if we don't end up in a world where the AI is able to do our job in 10 years or less, whatever, how likely do you think it is that we're heading towards a dead internet style problem where the noise generated or the noise created by these generated AIs is a problem to our own ability to communicate?
I mean, really, already it feels like so much of the internet is on like private discords that aren't on these massive public forums and linked with each other. I think that people are already kind of receding away from this like how it used to be, where it was like a massive graph of forum posts or whatever, right? Like, I don't know much about that. I mean, this is the internet and it's not dead, I guess. So it's not. I don't know. I mean, maybe people. So LLMs do seem like they kind of defeat the Turing test. And I think I'm remembering there was some news article. Somebody maybe in like Twitch chat or whatever can find it, where I think some lab basically plugged an LLM into like a subreddit and just had it be a commenter, and it got a lot of karma, and people started to like relate to it and like, oh, this is a good poster, he's a good guy, I like this guy. And then it was like uncovered that it was really like a false flag human being or whatever, and like they basically were doing a study on the subreddit involuntarily. I think people got very mad at that because it was like, that's probably not ethical to do to human beings. Most of what's happening in the modern world is not ethical to do to human beings, honestly. I don't think LLMs are that crazy compared to like YouTube. You just show infinite pixels to a person. It's like, this is probably not good for them. I don't know. Like, I don't really, things are already so far from what is like healthy for a human being. It's like, what do you want? Like, you just like it's not that much worse than TikTok. I don't know what to say. TikTok is a transformer. It's whatever.
So we talked about this over breakfast yesterday, but like LLMs, kind of cool, transformers, cool, doing something, but like there's a missing piece, or maybe many. Do you have any theories of what those might be?
Me personally, as a hobbyist, crazy person, I don't know. I feel like if I were to every single deep learning researcher is like, oh, it's going to be in reinforcement learning. Like you take that success of AlphaZero, where it basically can master any system, you just like apply that to like soft concepts, like Mu0. It's like, I think everybody is like thinking along those lines of like we basically need computers to automatically generate and master things that not even humans have mastered yet, right? Because if all you're doing is basically making these models try to optimize and find patterns like that are more and more closely match human beings, they'll never exceed the human baseline, right? I mean, they might be an ensemble of all the best humans, and they might be a genius in every single field or whatever, but they're never going to surpass human genius, which you would kind of want if you wanted to be a godlike being that replaces mankind, which is some people's goal, not mine. I'm not into that, but some people like that. I don't know. I think it's probably bad.
But like random thought, like what could that be like?
Reinforce. You need to have some way of operating on these concepts in a way, some kind of like gym, some kind of like imaginary, like it needs a world model, right? That's what OpenAI said, like, oh, we need a world model. It's like we need some way, we need a transformer not on text. That's why, so I don't know if you know this, but the reason why OpenAI did their video model is because of they're trying to solve this problem. They want a world model so that these AI systems can try to imagine new scenarios over and over again and find new ways to be better. And then, if you can actually, even if it's very inefficient at being better, right? If you can somehow correlate the strength of an AI system one-to-one with like compute, we can always get more compute, right? We can always make NVIDIA stock price go up and like get more chips from Taiwan. Like we can always keep ramping this, right? There's a lot of silicon on Earth and stuff like that, right? It's like, you can just keep doing this. You can scale it, and then once you have the compute, it keeps printing, it keeps being smart, and so it is only a matter of time until, if you can actually do self-optimizing intelligent processes with silicon that it exceeds human baseline and becomes the godlike figure that some people want to, will upon the Earth.
Sam, Timothy?
Oh, I had a question about like, is the future then like, or is there a data bottleneck at some point, and is the future reinforcement learning? So what I'm thinking about is like a baby, right, spends like a lot of time receiving input, and I have a theory that the reason puberty happens and like the body grows so quickly is because it's to like protect the brain from injuring itself while it's too dumb.
That kind of makes sense, actually. I don't know.
So is there a future where like you let robots like with cameras out in a field, and then the learning is just like what's the next frame of the video?
Yes, actually, exactly. That's like what NVIDIA is doing. That's like there's already many data sets where they basically just strap a GoPro to the center of a guy cooking in a kitchen, and there's like gigabytes of those videos, and the idea is just like, oh, we just basically need a lot of video of people doing whatever they're doing that's useful to other people. Throw a bunch of transformers at that $1 trillion AI company, and then we automate them, and then we rake in the money, and then there's no more people to buy because there's no more economy. It kind of just stops making sense. It's like really crazy. Like if you really think about it for a second, right? All these like VC-backed AI companies, if they really did pan out, there would be no more economy. Like what are you competing for by investing in that? I don't know.
So concerning like those gigabytes of videos and so on, I would imagine a big chunk of like what would make a training run effective is like how you transform the data before sending it into the model or into the algorithm, right? Because like I guess if you like filter down to what actually matters, because like, there's like a lot of when you have a guy cooking or something, like a lot of that image data is completely useless. You don't care about most of it, right? So like, what kind of pre-filtering do people do, and like how important is that?
Well, actually, people do the opposite of pre-filtering. Sometimes for deep learning, actually, I think Tesla's doing this. They don't feed pixels; they feed like raw sensor measurements. They decrease filtering. There's a very famous like blog post basically called "The Bitter Lesson," And the bitter lesson is that like a general method that scales with compute will always perform better than a specific method made by engineers, because compute is always getting cheaper and more plentiful. Engineers are becoming more scarce as people become stupider from the AI that you're creating and doing this. So.
Yeah, but even then by choosing to use like sensors, like you're making, that's like a deliberate choice. Like instead of using pixels, we're going to use sensors, so it's like maybe more relevant information we're feeding it. It's like the pattern might be easier to extract somehow, or?
No, it's not that. The idea is that we should not try to design these massive, trillion parameter deep learning models. We should not try to do any data transformation on what's happening in the universe, because it will find the representation that's most effective for minimizing the loss, right? It will do that with compute. It will find something better than what we could ever filter it, right? But basically what you're describing is, I think, called feature engineering, where like, oh, instead of feeding the images to the deep learning model, we try to detect like where the cones are and stuff and like the road, and then like, we feed those features into the model, and that always underperforms just feeding in the raw sensory data if you have enough compute to scale up, because the compute will find the representation that is most effective to output the policy, basically, I think.
So, but you can still select what kind of sense data you feed it in. Like the sensor is different from sense data from like vision, right? Like,
yeah.
You still make a choice, and like that choice will matter, right?
Yeah, the choice matters in the opposite direction from what you're saying. You want more generic, bigger amount of data.
Just feed it everything, every type of sense data you can get your hands on. Just feed it whatever you can.
Yes, ideally, yes. Like what they found, actually, I think there was this paper called like the NEMO paper. I don't remember what it was, but they basically had a transformer. They just found that as you taught it many random disparate games, it would like improve on the other ones, right? That were seemingly unrelated. And so there's something just about transformers, the more data that you give them, the better the representations become no matter what. I think it's because there's something kind of like a universal prior, or like, it's just the universe is ordered in a particular way that's evident in everything that happens in it. So the more information that comes in, by the way, this is not a true, I'm like crafting theories. It's like, maybe there's like something about the universe that just whatever you give it that's from the universe truly, and not, like a craft of man or whatever. Like it's just somehow builds better representations, because it's something like that. I don't know.
Like universal laws and patterns and such that just exist in reality, right? And like that's maybe what it's using somehow. Or?
That's maybe, yeah. I'm really not sure. I would like to see more rigorous attempts to answer that question rather than me like theory crafting. Are there any more questions? No.
I mean, just earlier, you beat me to it, but I was going to ask about just the noise, like impact of noise of generative AI on the internet, right? Because like if you lower the friction for like creating content, but like you said, it's like you're using existing data transformations to create things, then I mean, wouldn't the problem be like you just end up with so much stuff that is all from old transformations? It's really hard to find novelty among that. So like search engines get good enough that like we don't have a problem, or like is there...
No, there's just very easy ways to detect if something was output by AI for the most part, or like ways to filter for data that is like the most confusing for the model. And so these things are not going to be a serious problem for deep learning at scale.
Detecting AI or detecting information that AI has not seen before that's like possible, that's something that's like easy, you say?
Yeah, you can just tell which, training seems to be the most confusing to it. Maybe this problem is more complicated than what I'm thinking, because like maybe, I don't know. I'm sure there's much smarter deep learning researchers who have answered that question already, probably. But my guess would be that like it's probably not a real issue.
Okay, because if you could just filter out everything that's AI generated, that'd be really great.
Yes, they can. I think you can do that. Yeah.
Oh yeah, I hope so.
All right, we're out of time.
We're out of time. Round of applause for Creikey.